Today we're going to explain an important concept in refrigeration systems called superheat. At first, superheat can seem confusing. However, it's very important to understand because it provides a lot of useful information about how the system's performing. By understanding superheat, you can quickly check if the system is running efficiently and safely. So let's start with the evaporator, which is the part of the fridge that absorbs heat and keeps everything cold. When the refrigerant enters the evaporator, it is a low pressure cold liquid. As it moves through the evaporator, it absorbs heat from the air and from the items inside the fridge. This causes the liquid refrigerant to boil and evaporate, turning it into a vapour. Now, it's very important to note that cooling only occurs when the liquid refrigerant is boiling and changing into a vapour. During this boiling process, the refrigerant absorbs a large amount of heat, which is what provides the main cooling effect inside the evaporator. Once all the liquid is evaporated and turned into vapour, any additional heat simply increases the vapour's temperature. There is no longer any useful cooling inside the fridge, only additional heat being added to the vapour, and we call this superheat. So for example, if the refrigerant boils at -5 degrees, all the liquid is completely consumed and additional heat is added to the vapour up to 5 degrees. After fully evaporating, the superheat is 10 degrees above boiling point. This superheated vapour then travels to the compressor. It's crucial to only have vapour entering the compressor because liquid refrigerant can cause severe mechanical damage. So having some superheat ensures that all the liquid has been boiled off completely before reaching the compressor. When we measure superheat, we also learn important information about the refrigerant charge and system performance. For example, if the refrigerant charge is too low, there is not enough liquid entering the evaporator. All of the liquid will boil off too early in the evaporator, and the remaining part of the evaporator is only superheating the vapour instead of producing useful cooling. As a result, the superheat continues to rise and will be too high. If the superheat is too low, it may suggest that the refrigerant is entering the evaporator in too great a volume, and we call this flooding the evaporator, and there's a risk that liquid refrigerant may reach the compressor. In other words, the evaporator is not consuming all this liquid refrigerant, and we have a carryover of liquid onto the compressor suction line. Superheat measurements can also verify if the expansion valve or metering device is working correctly, ensuring the right amount of refrigerant is being fed into the evaporator. In short, measuring superheat together with subcooling can tell you a lot about the overall performance and health of a refrigeration or air conditioning system. By checking both values, you can diagnose problems, verify the correct refrigerant charge, and ensure the system runs safely and efficiently. Understanding and measuring superheat is essential for safe, reliable, and efficient operation of refrigeration and air conditioning systems.